Welcome to episode 3 of the Bomberman game development series in TypeScript. I wasn't exactly sure what I was going to put in this episode because there's so many things that currently have to happen at once. I kind of want to do at once. There's going to be some major restructuring. Well, let's just say some refactoring of how rendering works really, so we can expand easier. And of course the animation system. But I think the animation system is still something that we can add before we start refactoring a bit more. So that's exactly what we're going to build today. One thing that I left off last time. Oh yeah, one small thing. Well, two small things. One, I increased the size of my editor. Well, scaled up. It's really hard for me to see everything. I hope it's better for you. Do let me know if it's not. Or if it is, fine, let me know as well. I'll be happy to know. And two, I will try and show the end result right now. I tried to edit it in, and I will see how that goes. Hopefully I put something in here, and that's exactly what we're going to make today. So, first of all, last time we went off and we had an issue that I forgot about. We used document.addEventListener. We can't really use document.addEventListener because if we use document.addEventListener, then it will take every key input from our page. We don't want that. We want only the key input on our canvas, because otherwise, if there's something else happening on our page, then we might interfere with that, which we don't want. So we'll take our canvas element. And in our game, we'll pass it along. Is it in the setup? I took it? Yeah. This is our canvas element. Okay. There's one issue that we have. I can't show. One sec. Don't have the actual game open. Don't actually have the actual game running. Good start. Come on. Come on. That's a great start. Okay, there we go. We'll zoom out a little bit. Okay, so the issue is now we can't move because Firefox will start thinking that we're actually trying to search, because the issue is we don't actually have the canvas element selected, because you can't select the canvas element by default. So what we have to do is make it selectable, and we do that in HTML by giving it a tab index. And now we'll be able to select the canvas. The issue is still, if we load the page, the canvas is not loaded by default. We're going in our Bootstrap, TS, select, focus on our canvas element. The reason why we do it in Bootstrap is because if you have multiple games on one page, then you want to still be able to focus the right one without your game focusing itself for some reason. By the way, if you hadn't noticed, the Bootstrap code is actually the code that would go outside, that stays outside of the game. It's not really part of the game, and it could change depending on how and where you want the game to run. Okay, so as we can see, we load the game and now we can move instantly. Exactly what we want. Okay, now our player. Let's animate our player. Last time we added these images in our forward, backward, right and left. Today we're going to not use these images anymore because they would be way too inefficient. The issue is, once we start having animations, let's say in our case 8 images for every animation, so that would be 8 for forward, 8 for backward and so on, then we would need 32 images. That would be insane if we just requested 32 images from our server every time someone started a game, and that's just the player, right? So obviously we're going to use a sprite sheet. I've already put in a sprite sheet on the server side. I've made a sprite sheet with not Photoshop. I'll put what I made it with in the description. I completely forgot the name of it, but whatever. You can find this one on Github, on the Github server, and download it there, or just pull the Github really. Yeah, it's fine either way, because this is the only change we're really going to make this episode to the server. So let's load that image. Okay, we've loaded the image, and now we could use that image and try to render it properly, but what we kind of need is a different class to handle all that for us, because it would be too complicated to put it in player. So let's make a different class. Sprite sheet. We'll take three things. It will take an image, which will be the sprite sheet image, and it will take sprite height and the sprite width. This will basically be the width and height of every single sprite in the sprite sheet. Yeah, exactly. There will be like we know this sprite sheet will have. We know this sprite sheet. Fucking hell. We know every sprite in this sprite sheet will be 64 by 128. Meaning we can just make it a bit easier, add that to our class, and we can just say I want the third sprite on the second row, meaning 1, 2. Now we have the third sprite on the second row. That's much easier. Well, 2, 1 it would be, but whatever. So sprite sheet, what am I doing? Constructor, we're not using Java. We're going to take all these parameters. Okay, so our sprite sheet is also going to have a render function. That's why it has this sprite width and sprite height, to make it a bit easier to write that render function. Okay, our render function will take three things. First of all, it will take the game data. Second of all, it will take which sprite we actually want to talk about. So that will be x count, y count, meaning how many, which sprite on the x-axis and which sprite on the y-axis. Can't forget the commas. And then it will have the actual position and dimensions that it has to be rendered on the screen, where it has to be rendered and how it has to be rendered. Okay, and now we can use the context to draw our image. This one takes three kinds of parameters again. First of all, the image. Second of all, the source position. So where is the position that we want to render? Like we take a cut from this image, and that's our source. In this case, that will be x count. Meaning, say, like this, in this case, our sprite width is 64. If you want this sprite, then we say 1, and it will be 1 times 64, and get this one, which is perfect. Same for y. Typo. And then it will have it will take our destination, where exactly we want to go, which is basically the same as these four parameters. There will be x, y. There we go. And that's our render function done. Now, in our player, let's make our sprite sheet. has a width of 64 and a height of 128. Okay, now we don't want to render them manually every time, of course. That would be a bit stupid. So what we're going to do is change that. Now, as you can see, we just use sprites here, and we currently only allow sprites to just take an image, but we kind of want to have sprites that can take an image or take a sprite sheet. So we're going to change that a bit to be able to take both. So what we're going to do that is we're going to make Sprite into an interface. Which will take, where's my Sprite? Okay, which will have a render function always, because that's the one we kind of need. Okay, and now this sprite will become an image sprite. Where nothing really has to change except for player, which will have an image sprite, and it will also have to take a sprite for this one, for this type, and these will be image sprites. Okay. Okay, and then once we have that image sprite, we can create a sprite sheet sprite. Take a few parameters. It will take the sprite sheet. The X count and Y count, which are the positions on the sprite sheet. And our flipped X, which we use to flip the right sprite to serve as the left sprite. Let's take those parameters. And now we obviously also take a render, but less. I completely forgot to do that in our sprite image sprite, I think. Yeah. There we go. Same as happened here, and it generated a render function. In VS Code, it generates a render function for you. Well, it generates a function for you from an inheritance. Well, from, let's just say, an interface or an abstract class, whenever you just save. So we'll just throw an error and you'll be able to save and it will just generate it for you. So let's render. one thing we forgot is our sprite sheet doesn't have the flipped state, and it has to take that in the render, because obviously we can't take it in the constructor, because if we take it in the constructor, then everything in the sprite sheet will be flipped, and we don't want that. Oh my goodness. Typing is not a strong suit today, it seems. There we go. And now we have to implement it. Let's take it from image sprite. And obviously you already start to see that this is just a repeat, right? We're repeating things and we never want to really repeat things. But what we generally do is we just repeat it anyway and then refactor it later. Because we don't want to be refactoring while we're actually trying to implement a feature, because that will just make it much more prone for errors. 2 errors, 4 errors, I'm not sure. And this is all flipped. Flipped x will be this is all flipped. Oh my goodness, flipped x. Okay. In our player, we can now make sprites, and instead of image sprite, we'll make a sprite sheet sprite. Sprite sheet sprite. We'll take our sprite sheet. It will be forward will be 0, 0, and it won't be flipped. Backwards will be 0 and 1 on the y-axis, and I'm just going to copy and copy. Left. Right will be 2 on the y-axis, left will also be 2 on the y-axis, but it will be flipped on the x-axis. There we go. And now our game should still work. Okay. Doesn't work if we go right, so we fuck something up. 0, 2, that's right. So if we take flipped out, we should just see moonwalk, right? Yeah. Okay, let's go to our sprite sheet, which is probably where the issue happens. Oh. We take rendered x because if we flip the context, then we have to render from the other side. Much better. There we go. Now that we have that, we have sprite sheets and we can actually make our animation, finally. Okay. I'm good on time. Let me have a look. Yeah, let's make an animation. Our animation will need a few things. It will need the sprite sheet. It will need frames that have to be shown, which we can make a type of frame. What I'm going to do is just going to make a frame as 2 numbers, meaning x and y, meaning where exactly on this sprite sheet that we want to select our frame, right? So say for example we take 1, 1, and it will be this one. And we want an array of that. Now we want to take how many milliseconds every frame takes. You could also add that into the frame, just make it an object, or just add a third parameter. But what I kind of want with this one is just to have a uniform animation, meaning every frame in the animation has the same duration. Just about the same duration now. So ms in current frame to 0 and private current frame index, which are two things we need. Which are 2 things we need to actually just animate frames. Take our constructor. And then we'll make a render function. We'll need the delta to actually do the animation. Put that. And then we have our XY width and height. Okay, now we'll first update the frame, and I will render the frame. Meaning, like, we'll first update which frame has to be rendered as well. So we add in seconds. Well, sorry. So we add in milliseconds how many time has passed since the last frame, and if then we just say, then we go up a frame, or let's first do the timing functions. Okay, and now we'll just update how many milliseconds there are the current frame has happened for, check if it's more than, if that is bigger or equals to the actual milliseconds that we want one frame to happen. Then if that's true, then we'll just take that off. The reason why we take that off instead of just saying equals 0, you can really do both, but I kind of want the whole loop of animation to be the same instead of just having one frame to be the same, to be always the same length, let's just say. So I'm happy to have some issues there. Current frame index, add to it. If it's bigger than the maximum, then we'll just put it back at 0 and keep going with the animation. Okay, then we'll actually render the frame, which will be sprite sheet render, takes the game data, X count and Y count, which will be current frame. Let's get the current frame. Okay. And then the rendering position. And once again, we have to take that flipped variable. You would think after writing it so many times I'd know how to fucking do it. Okay, and as you can probably tell by now, then as you can probably tell by now, this is one of those things, once again, that we're repeating over and over and over again, which is really not what we want. So that's one of those things that we're going to try to get rid of next tutorial. Well, we're not getting rid of the flipping, we're just getting rid of having to repeat that everywhere. And we're going to find a system to actually flip it for us. Okay, just go flip X, right? Yeah. Anything else? Nope. Okay, in our player, let's try that out. Okay, one more thing we have, one more issue we have in the player is we want to render it, right? But we kind of don't want to just render our animation. All right, let's actually fuck it, let's do it anyway. I'll make that statement in a bit because it's not as obvious right now. Oh, that animation. I don't want that animation. Will I have to use a different word than animation? Please don't. Ah, never mind. Sprite sheet, and then our frames. We're not going to do all of them manually, obviously. Let's just do 0. It's X. So I'm going to change this here to animation. Just make sure it doesn't crash. So now we should have some really basic animation. Oh, we should still have to render it because we have to pass the delta to the animation. What happens? Is there an error? Current frame is undefined. Let's have a look at our animation. Oh, this should probably be equals, because the maximum frame index is 7, well, is, say, for example, 7, whereas the frames.length will be 8. So if it's 8, then it has to go back to 0. Okay, there we go. As you can see, as he's stomping with his foot, he's being animated. So now we have to make a bit of a, we have to make something that will make writing these frames easier, right? I'll just put that in the animation for now. Actually, no. Make a range function, a range class to have a public static range x, row number, call count, both be numbers, and then let me think. I kind of forgot how it works. Let me think. So it's array.from new array with call count, and a second was a function which would just have to say row number, no, I and row number, just a callback with the value and the index of the array. So we pass a new array and we get the index and the value, but it doesn't have a value, right? But that doesn't matter because the index is 0, 1, 2, 3, which is exactly what we want. So we just pass back our I and row number, which will initialize this array with values, meaning these values. Sounds a bit weird, but it will just make one of these. Range dot row range. What? Row range, and we'll have row number will be 0. Yeah, 0, and call count will be 8. I want that to be the frame, so it's animation. That's fine, to be honest. Does that work? Huh. Okay, there we go. Just have to specify, I guess. This will be flipped. Do we not have a flip setting here? No, we do not. We have that setting here. let's put it here. We don't want to have to pass that every time we render. One more thing, this comment. And now we should be able to pass flat x through. Let's see how that goes. Well, that one doesn't work. Forgot to pass in the right row. There we go. Beautiful. Alright, now we don't have the idle stance anymore. So what we want to do is add an idle state in here. And that way we actually start building kind of an animation state system, right? Because we're setting the state of the user, and then this list of sprites will just handle which one has to be rendered, if that makes sense. So that's exactly what we're going to set up now. Well, not that system. I just mean we kind of need an image for idle. We don't want the whole animation. We could just go animation and then just have a single frame, but that would be ridiculous, right? Now, one thing we have are these sprites. The difference is these sprites don't take a delta because we don't really need it, but it should still take a delta. It could still take a delta because it's part of the overall thing, right? So we have a sprite and we pass our delta. That's the normal thing to do. It doesn't matter that some of these sprite implementations don't use it. We'll still use it. We'll still get that done. So we'll use a sprite. Where is our sprite? Oh yeah, in types. And we'll take delta. This will become even more obvious once we split our render into update and render, which is something we're doing next episode, by the way, because that's something that's really important, and I kind of want to take my time to explain why it's important to have a separate render and update function. So I'll just, if there's any episode you watch, next time's probably the most important one. The most important one. Okay, so our sprite sheet will now take delta, and our sprite sheet sprite, and our image sprite will also take delta. And our animation can now become a sprite. Well, we don't really have to change anything, everything's already set up, right? And meaning in our player, we can change this back to sprite. And for our idle position, we can just use an image sprite. Sprite sheet sprite. Which will take our sprite sheet. And the position. And then we have, in our get moving sprite function, we actually have to use that. So if velocity y and x are both 0, then we're obviously idle, and as you can see, now we have an idle state. Fantastic. Okay, that's really all the code we're going to write for today, because it's already starting to get quite long, and I'm going to try to keep our videos from now on around half an hour. I do want to get some decent content into every video, but I don't want to make them too long so that you can't just watch one video in one sitting. So what we're actually seeing now, though, is that gradually we're building more and more complexity. And a big thing that we've actually built now today is the render system. And it doesn't look like we have yet. Well, it's not today, but over the past 2 episodes, it doesn't look like we have. But next episode, you'll see that we can now refactor this to make it a bit cleaner. I'll show you why we make every decision. And afterwards, you'll see that the whole system is just much cleaner that way. If you know what I mean, like it will all start to make a bit of sense why we made certain decisions and how we get to a system that we can actually expand on. And hopefully, once that's done, we can actually start getting some content in really quickly and actually start to get to our game, because we actually have to make a multiplayer game here. And I don't want that to take 200 episodes. So I do hope you enjoyed this episode. Let me know what I could do better. Let me know what you think. And that's it, really. Like and subscribe, whatever. Just hop on the bandwagon there. And I'll see you in episode 4. Bye.